So we're going to review atomic structure and electron arrangement and nuclear chemistry. Now on the review sheet, which is in the last 2 pages of your notes packet, I did forget to put on average atomic mass calculations. So I am going to do the 3 problems and remind you how to do them that are in the extra practice. So we have 3 problems here. Number 1, rubidium has 2 isotopes. This should really be 85 over Rb as a nuclear symbol and 87 Rb. If the abundance of Rb85 is 72.2, abundance of Rb87 is 27.8, what is the average atomic mass? So remember, we're going to do percent times mass plus percent times mass until we run out of numbers. So we have 72.2%, and that corresponds to the rubidium 85, plus 27.8%, which corresponds to the rubidium 87. Now, the easiest way to do this is to just hit it all into your calculator and then divide by 100, and you should get 85.56. Now, if there's 3 isotopes, you have to do this 3 times. So we have 0.01% of the uranium-234. We have 0.71% of the 235. And we have 99.28% of the uranium-238. So hit that all into your calculator, hit enter, divide by 100, and you should get 237.98. Units are AMU. Okay, and then for number 3, we have 5 isotopes, so you just got to do this 5 times. 8% times 46 plus 7.8% times 47 plus 73.4% times 48 plus 5.5% times 49, and we have one more, 5.3% times 50. So hit it all into your calculator, hit equals, divide by 100, and you should get 47.92 AMU. Okay, so you will get one of these on your test, on your next test. This is just extra practice on the chart, and there's the answers, but there's a smaller chart down below, which we are going to go over. So I've already done the completing 1 through 3. Number 1, I will go over at the end. But I am going to talk about this chart quickly. And so remember, a nuclear symbol, we have the mass number goes up top. I want to do this one. The mass number goes up top. The atomic number goes down below. Then we have the element symbol, and the charge goes here. Now, mass number is going to be protons plus neutrons. Atomic number is protons, and the charge is protons minus electrons. Okay, so you need to know how to get the mass number, how to get the atomic number, how to get the charge. The atomic number you can find right on the periodic table, and it's the whole number in the square on the periodic table. So for number 2, remember this is hyphen notation. This number right here is the mass number. To convert to nuclear symbol, the mass number goes on the top. You look at the periodic table and put the 32 down below. And then we have just germanium, Ge. Remember, the symbols are on the periodic table, so you should not get the symbols wrong. And the first letter is capital, second letter is lowercase. Now, there's no charge in the hyphen notation. There's no charge given here. So therefore, we have a charge of 0. Protons is equal to the atomic number, which is the bottom number right here. Neutrons is 73 minus 32, which is 41. Electrons, since there's no charge, it's the same as the number of protons. Now, if we're given protons, neutrons, and electrons, we should be able to work the other way. So protons is 20. So that would go at the bottom in your nuclear symbol. You look at your periodic table. Calcium has an atomic number of 20. Then your mass number is 20 plus 21, protons plus neutrons. So we get 41 right here. I have 20 protons, 18 electrons. 20 minus 18 is positive 2, and I need to remember to put that into my nuclear symbol. To convert to the hyphen notation, you just write out the element symbol. Mass number goes after the hyphen. If there's a charge, we typically don't include it. Okay, next one. All we're given is the nuclear symbol here. So to convert that to hyphen notation, the 14 is our mass number. That's going to go after the element name. The 7 that's here, that's our atomic number. Neutrons is going to be is 14 minus 7, mass number minus atomic number. Right now, we don't have a charge here. There's nothing written here. So it's a charge of 0. So therefore, our electrons equal our protons. Now, just an aside, if this was 14 over 7 nitrogen with a negative 3, our protons would be 7, our neutrons would still be 7, our charge would be negative 3, but we need to remember that if it's a negative 3, it's gained 3 electrons. I have 3 more negatives than positives, so my electrons are going to be 10. Okay, mass number we already talked about, protons plus neutrons. Atomic number is protons. Protons you find on the periodic table. Isotopes, atoms of the same element with different numbers of neutrons, which another way to say that is different mass number. So if I have carbon 12 and carbon 14, these are isotopes because I have different mass numbers. If I have something like oxygen with a negative 2 charge and no charge, these are ions and a neutral atom. And then if I have something like oxygen 16 and carbon 12, those are obviously different elements, but the number that tells you is the atomic number. Okay, difference between fusion and fission. Fusion, we fuse together, we mush it together to form one thing. So it's 2 or more things coming together to form one thing. Fission, we split apart, we break it apart. So one thing is going to spontaneously split into 2 or more things. What powers the sun is fusion. What we do on the planet is fission. All right, half-life. So you are going to do a half-life calculation on the test. In order to do half-life, remember, you always start with 0 time and the initial amount given in the problem. So our half-life is 12 minutes, and we start for 100 grams. And then we want to know how long it's going to take for it to get to 12.5. This should be grams, not milligrams. So after one half-life, remember, you're always going to be adding the half-life as we go through the top. So after one half-life, 12 minutes has gone by, and we have the amount. After a second half-life, I add 12 again, and I have the bottom amount. After 3 half-lives, I add 12 again, and then I have the final amount. And since it says how many minutes, my answer is 36 minutes. Number 5, we have a half-life of 5 years, and I have 40 grams. Remember, I start with a 0 time, 40 grams. And remember, half-life, I add the half-life, and then I have as I go across. So we want to know how much remains after 25 years. So I just have to say, well, 1 half-life is 5 years, 2 is 10 years, 3 is 15 years, 4 is 20 years. 5 is 25 years. That's what it's asking for. Now I have to keep having it until I get to that point. So 40 goes to 20, 10, 5, 2.5, 1.25. There's my answer. Symbol for alpha, beta, gamma, and penetrating power. So alpha is 4/2 helium. Beta is 0/-1 electron. Gamma is 0/0 with that dead fish. And remember, for alpha, you can also use the Greek alpha or the beta. And the lowest penetrating power is alpha. Then in the middle is beta. And the highest is gamma. Gamma is just straight energy, no mass. All right, for the following nuclear reactions, the first two are already done for you. These are hard to find and hard to write, so usually I just pull them off the internet and just do some snips, but sometimes there's some mistakes. But remember, the top numbers, so top numbers here, have to add up to the same value as the top numbers here. So on the left, I have 27 plus 4 equals 31. On the right, I have 30 plus 1 equals 31. The bottom, I have 12 plus 2 equals 14. 15 plus 0 equals 15. Oh, this didn't add up right. 12 plus 2. So I'm actually missing a 0/-1 electron. I think if I did this right, 30 plus 1 is 31, 27, 31, 12 plus 2 is 14, 15 plus 0 is 15. So it is missing an electron. So I'm not going to give you one like that. So we can skip the first two. But for the second one, or for the third all the way down, we have 65 on the top. That has to equal 65 plus something. So therefore that top number is 0. Okay. The bottom, 30, has to equal 29 plus something. That has to be a 1. A 0/1 is something called a positron. I'm not going to give you that. You will have to do alpha, beta, or gamma. We are just practicing the process here. Okay. Number 4, I have 9 plus 4 equals, that's going to be 13. On the right-hand side, 12 plus something has to equal 13. They have to be the same number. Therefore, it has to be a 1. And then I have 4 plus 2 is going to be equal to 6. I already have a 6 here, so that has to be equal to 0. 1/0 is a neutron. For number 5, I have 31 plus 2 is 33. So 32, what am I missing? I'm missing a 1. 15 plus 1 is 16. 15 plus 1 is 16. I look on the periodic table. The element that has an atomic number of 1 is hydrogen. Okay. This is just written backwards. Number 6, we have 35 plus 4 is 39. Therefore, 37 plus what equals 39? Has to be a 2. The bottom, I have 16 plus 2 is 18. 17 plus what equals 18? Has to be a 1. Look on the periodic table, and that is hydrogen. Here we have 30 plus 1 is 31. 30 plus 1 is 31. 14 plus 1 is 15. 15 plus 0 is 15, and that would have to be a neutron. And then the last one, 2 plus 2 is 4. 1 plus 3 is 4. 1 plus 1 is 2. 1 plus 1 is 2. Look on the periodic table, and that is hydrogen. Okay. You do need to be able to answer questions like how many sublevels are in each energy level? What sublevels are in each energy level? So remember, the first energy level only has an S. The second has an S and P. Third has an S, a P, and a D. The fourth has an S, a P, a D, and an F. So the first energy level has one sublevel. Second has 2 sublevels, third has 3 sublevels, fourth has 4 sublevels. Every S can hold 2 electrons, every P can hold 6 electrons, every D can hold 10, every F holds 14. So our total number of electrons in each energy level, 2 for the first, 8 for the second, 18 for the third, 32 for the fourth. And remember, if we ask how many orbitals are in S, P, D, and F, and S has 1 orbital, P has 3 orbitals, D has 5, F has 7. And remember, orbital is the equivalent of number of rooms. All right, Aufbau, Hund, Pauli. You don't need to know the definitions, but you need to know how to use them. Aufbau is lowest energy first. Hund's rule, shortcut, is up, 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 down, down, down. Pauli is when you have 2 electrons in an orbital, they have to be paired or they go up, down. So the first example, carbon, you look on the periodic table, 6 electrons. First 2 go in the 1s. Once that's full, second 2 go in the 2s. When we get to P's, D's, or F orbitals, you're going to put 1 in each before you pair up. So I've already put in 4 electrons, 5, 6. And remember, we need to have 1 in each orbital before we can go and pair up. Phosphorus, I look on the periodic table, 15 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And remember, I did 1 up in each before I go back and I pair. To do the electron configuration in the abbreviated, you're going to use your diagonal rule. You will have a diagonal rule on the back of your periodic table. I'm just going to draw it here quick. Then we have 3D and then 4F. And I'm not going all the way down because we're not going to go that far. Then you're going to draw your arrows. So it goes like this. This is all on your periodic table. And then we're going to write, which is on your periodic table, on the back, helium, neon, argon, krypton, xenon would be here for our abbreviated. So when we go to do the electron configuration, we look on the periodic table. Sodium has 11 electrons. And you just follow the arrows. 1s comes first, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, 4p, 5s. And you just keep following those. And you do have to remember the s holds 2, p holds 6, d holds 10, f holds 14. So to do sodium, it's 1s2, 2s2, 2p6. I have now put in 10 electrons. I'm at the 2p6. Then I have to go to 3s. I only have 1 to put in the 3s. So it's 3s1. Iron, we follow our diagonals. 1s2, 2s2, 2p6, 3s2, 3p6. But remember, when I get to 3p, I have to follow the arrows. 4s comes next, not 3d. So it's 4s, then 3d, then 4p, then 5s. So then we go to 4s2, 3d, 6, because I only have 6 at the end to put in. I'll do bromine and then we're going to move on. The answer for cadmium is right there. Again, you follow the arrows. 1s comes first, then 2s, then 2p, then 3s, then 3p, then 4s, and you just keep working your way through until you have added the appropriate number of electrons. How do I get that? I get that from the periodic table. Bromine has 35 electrons. Therefore, I have 35 electrons in a neutral atom. And Aufbau says the first 2 go in the 1s, then the 2s, then 2p, then 3s, then 3p. S's can hold 2, p can hold 6, 4s2. And remember, now I'm at 4s2, then 3d comes next. So 3d, then it ends with 4p5. Now to do the abbreviated, remember on the periodic table you find cobalt. You go up one all the way over till we get to group 18, and that element there is argon. So by writing argon in brackets, I have written the electron configuration for the first 18 electrons. Now to continue on the diagonal rule, we find argon and we just pick up from there. So after argon comes 4s. S can hold 2. Then comes 3d. And then that would be your 27 electrons. Silver, you do the same thing. You find silver. You go up one all the way over. Then that's going to be argon with 36 electrons. I'm sorry, it's krypton, not argon, it's krypton. So then I write krypton in brackets, and that represents 36 electrons, and I need to put 11 more. And so I go to my diagonal rule. I find krypton, which is right there. I start at krypton and I continue. The next one is 5s, and then 4d9. And then the last one you can do on your own. Now this is new, but this is looking at electron configurations and trying to see if they were done correctly. So we look at the electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. But if we follow the diagonal rule, this should not be 4d, it should be 3d. So that's not correct because it's done out of order. The next one, 1s2, 2s2, 2p6, 3s3. S can't hold 3 electrons, it can only hold 2, therefore it's not valid. Here, radium is not a noble gas. Radium is in group 2, I believe, but it should be radon, which is in group 18, which is way over on the other side of the periodic table. And then the last one, krypton. After krypton does come, if we look up here, 5s2, then 4d10, 5p5. There's no mistakes. We are good. All right, and then the last thing is looking at the particles, protons, neutrons, electrons, knowing their location, mass, charge, and purpose. So a proton is in the nucleus, buried in the nucleus, and it's got a mass of 1 AMU. So which means it is a heavy particle. It has a charge of +1. It's not just positive, it's +1. And the purpose is the identity. And remember, that's the atomic number, which can be found in the periodic table, in the square, the whole number. Neutrons are in the nucleus. They're buried in the center. It is also a heavy particle because it's 1 AMU and its charge is neutral. And the purpose of neutrons is stability. It allows an atom which should be unstable with all those positive charges smushed together. The neutron helps stabilize it and allows it to exist. And remember, to get your neutrons, mass number equals atomic number plus neutrons, or protons plus neutrons. And finally, we have the electron. And the electron is found outside the nucleus. It is a very light particle. It's about 1/2000th an AMU. So the mass really doesn't affect the atom, but the charge does. The charge is -1. And the whole purpose for electrons is reactivity. This is why we do the electron configuration, because you're going to see next chapter and the chapter over, those electron configurations are going to help us predict how an atom is going to react. So I hope this was helpful. If you have any questions, feel free to email me. Good luck on your test.